Okay, let's do the first lab. In this scenario, the user network uses two subnets, 10.1.10 and 10.1.20. The latter is the secondary subnet. VLAN is being used, VLAN number 1 is being used, and you must configure router 1 through 4. That will be the default gateways for this network. So let's go to action item number 1. Configure only the default gateways for this network using a CISCO redundancy protocol. The default gateway IP addresses must be 10.1.1.1 and 10.1.2.1. Also, router 1 must have more priority than router 2. Router 2 must have more priority than router 3. Router 3 must have more priority than router 4. Start with router 4. Okay, let's go to do that. And go to router 4. Basically 1, 0. And stand by IP. This will be the default gateway IP address for the primary subnet, and then the standby IP 10.1.1 secondary. The priority, I'm going to choose 100. So show standby will tell me that this router is in a speak state. Then it will go to standby. Then it went to active. So active router is local, preemption is disabled, there is no standby router, and this is my priority. Okay, let's go to router 3. Show standby, send listening state, then speak state. Standby. So after a negotiation, it turns out this router 3 at this point is the standby. So let's configure router 2, and the active remains being the router 4. Okay. So after a negotiation, this will become the standby because it has higher priority than router 3, but it didn't become the active router. So let's configure router 1. So let's see how it ends. Listen, it will have to go from init state to listen state to active state, then to standby. Okay. So router 4 is active. Router 3 is listen. Router 1 is not. Router 1 should become. Oh, I commit a mistake here. Priority should be the highest. So at the end of this, we'll have router 4 is active. Router 1 should become a standby. There it is. Router 2 and 3 are listening. So check if there is any asymmetric traffic. Let's see. Let's go to PC1. Let's see if I can ping the internet. I can. I'm going to trace. And this shows me that I'm going through the internet to router 4. That is correct because it is active. Now let's go here and trace that PC, and it shows that it is going through router 1. So we have asymmetric traffic because router 1 should be the default gateway. Why is it asymmetric? Because the one connection was configured with ENCORE, and according to the topology, there is a lower delay to router 1, more delay to router 2, more delay to router 3, and the highest delay is configured to be with a router 4. So the one expects that the default gateway for the network is router 1. So that's why we have asymmetric traffic. So why did the current active router become active? Router 4 became the active router because it was configured first. And given there is no preemption, that is why it remains being the active, even though it has the lowest priority of all. Another thing I want to check is what is the MAC address that is being seen. So the MAC address for the default gateway is this, that corresponds to HSRP. HSRP will change these last two digits in order to accommodate 255 groups. So this is a virtual MAC. This MAC actually don't belong to anyone. So this is the active MAC address that is in use, that we'll have to be moving among devices. Okay, let's go to action item number 2. Make router 1 become the active traffic forwarder. Make sure future object tracking configuration will work. Check if there is an asymmetric traffic. Okay, so we have to configure standby. Preemption. Standby preemption. In real life, you will have to use delay because you don't want any eventual intermittence in your LAN to create or start changing your HSRP modes. So always use delay. I'm not going to use it for this lab, but always use delay. This is doing something. It is already standby. I only had to configure this in router 1, but I'm going to do it at every router. So that way I will assure that if I configure object tracking, it will work. So check if there is any asymmetric traffic left. So let's go to PC1 and let's trace 81. I'm now going through router 1 for the upstream traffic, and I'm going back to router 1. So this is working correct. Okay, correctly. Action item number 3, configure object tracking on routers if interface P6 goes down, subtract 20 from the priority. Test this config, shooting down post 60 at each router. starting at R1, validate the roles and check traffic, asymmetric traffic. Okay, so we need to add object tracking. Notice that if I don't specify a group number here, by default the configuration goes to group 0. So I'm going to track the one link, and I'm going to subtract 20. Okay, and I'm going to test it. I'm going to shut down interface 60 in order to simulate a one link failure. So when I do that, the priority goes down by 20, given preemption is enabled. This router is no longer being the active. It gives up its role, and router 2 will become the active router. So if I go through here, now I'm coming back, I'm coming up with router 2 and coming down with router 2. Okay, let's simulate this at router 2. Shut down, and this priority came down to 90. So this router gives up being the active router, and now router 3 becomes active. Now router 3 is active. Let's see PC1. I am now reaching the internet through router 3, and let's see if there is asymmetric traffic. Now I'm coming down through router 3 as well, so traffic is okay. Now let's simulate the same here, down, and router 3 must give up being the active router, and router 4 must take over. Now for PC1, I'm going up through router 4, and the traffic is returning on router 4. So, okay, it's okay. Action item number 4, restore the network and simulate a human error at switch D. Change interface U01 to VLAN 2. Okay. This is something that can happen, and we'll have to restore the session. You must restore the active role to router 1. So now router 1 should be the active. But what happens if the engineer that is configuring this switch makes a mistake and configure this interface with the wrong VLAN? So in this case, router 1 becomes isolated. The interface 1 is never going down, so router 1 believes that it is still being the active, whereas the other routers believe that router 1 is gone So I have two actives in this network. Router 2 believes it's active. Router 1 believes it's active. So it is all due to a misconfiguration in the LAN switch. So the other routers believe that router 2 is the active. Router 4 believes that router 2 is the active one. Router 3 believes that router 2 is the active one. Router 2 believes he is the active, and router 1 believes he is the active. This is because the broadcast domain was broken. So it's broken. So this kind of issues are not easy to resolve. You will usually must use an IPSLA and a tracking object and use embedded EMM. So you'll have to use many other technologies in order to solve these kind of issues. Okay, that's it.